So this is question 2 from the Edexcel AS A-Level Maths 2018 paper. So the first set of exams for the new A-Level. So question 2, we were looking at a couple of proof type questions. For part I, or part 1 should I say, we've got to show that x squared minus ax plus 17 is greater than 0 for all real values of x. So the easiest way to actually go about this is just to complete the square on this quadratic expression here. This x squared minus ax plus 17. So if we complete the square on this, let's have a look at what we get. So remember, we start like this. Half this expression here, that's going to be minus 4. We're going to square the full thing, like that. So we're going to get a minus 16 on the x side. You just take the negative square. That's going to be minus 16 plus 17, so that's going to give me plus 1. Well, what do we have here? Well, we have a number, no matter what value I put into here, I'm squaring it. So if this is negative and I square it, it will always be positive. And obviously, like it's positive and I square it, it's going to be positive again. And I'm adding another positive. So this can never be smaller than 0 or negative. So because this is positive, always pos, and because this is always positive, so plus 1, it is always greater than 0. So write that little last statement in, in words, and just say this is positive because we're squaring it. This is always positive, so it can never be negative. The other way to look at it would be to look at the minimum, the turning point of this quadratic here. This is minus 4, so the turning point t dot p would be 4 and 1. So this is clearly, if this is the lowest point on the quadratic, because it's a positive quadratic, so it'll look something like this. Just as an example, it might look something, that's a bad sketch, blah, 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 blah. Ignore that a second, guys. Hang on. So say it looks something like this, right? Bad sketch, but you get the idea. If it looks something like that, this is my minimum point here. It's always positive, right? It never goes under the x-axis. So that again just clarifies it in clearer expression. And then part 2, we've got a statement here. If I add 3 to a number and square the sum, the result is greater than the square of the original number. And it says state given a reason if the above statement is always true, sometimes true, or never true. If you ever get a question like this where it asks, is it always true, sometimes true, or never true? I think a good way to go about it is play around with a couple of examples, right? So it's saying if I add 3 to a number and square the sum, the result is greater than the square of the original number. Well, if I picked 1, for example, as my number, 1 plus 3, well, that's 4, right? We don't need to be doing A-level maths to work that out. It's 4. If I square this, 4 squared, that's 16. Well, 16, 4 squared, is clearly bigger than 1 squared, right? So 4 squared is bigger than 1 squared. It works for that, right? But what happens if I pick minus 3? If I pick minus 3 and I add 3, well, that gives me 0. Hopefully that's clear to see. I just get 0, right? Well, if I square this, 0 squared, well, that's just going to be 0, right? Well, if I square the minus 3, though, that's going to give me 9. Well, this isn't what we want, right? We wanted to show that this expression here, the sum of, minus 3 plus 3, is bigger than the square here, but it's not. 0 is not bigger than 9. So 0 is not bigger than 9. So therefore, we can say it's sometimes true, because we've proven that it can be true, and we've proven that it can't be true for some expressions, namely the negative numbers. So there you go. And again, it doesn't have to be minus 3. It could have been any expression in the negatives, pretty much. So, play around with it and see what you can prove. But yeah, that's 3 marks for part A and 2 marks for part